Welcome again to my channel. Thank you so much for subscribing my YouTube channel, Science Time Discussion. Our lesson in this video will discuss the topic, the electromagnetic spectrum. The electromagnetic spectrum is the range of frequencies of electromagnetic radiation, their respective wavelengths, and photon energies. Let us define first the following terms: frequency, wavelength, and photon energy. Frequency in physics, the number of waves that pass a fixed point in unit time. Also, the number of cycles or vibrations undergone during 1 unit of time by a body in periodic motion. Wavelength in physics is the distance between successive crests of a wave, especially points in a sound wave or electromagnetic wave, while photon energy is the energy carried by a single photon. The amount of energy is directly proportional to the photon's electromagnetic frequency and thus, equivalently, is inversely proportional to the wavelength. The electromagnetic spectrum is a continuum of electromagnetic waves arranged according to frequency and wavelength. It is a gradual progression from the waves of lowest frequencies to the waves of highest frequencies. According to increasing frequency, the electromagnetic spectrum includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Gamma rays, X-rays, and high ultraviolet are classified as ionizing radiation as their photons have enough energy to ionize atoms, causing chemical reactions. These waves do not have exact dividing region. The electromagnetic spectrum covers electromagnetic waves with frequencies ranging from below 1 Hz to above 10 to 25 Hz, corresponding to wavelengths from thousands of kilometers down to a fraction of the size of an atomic nucleus. This frequency range is divided into separate bands, and the electromagnetic waves within each frequency band are called by different names, beginning at the low frequency, having a long wavelength, and the end of the spectrum starts with the radio waves with the lowest frequency at the longest wavelengths, and in the other ends with gamma rays at the highest frequency with the shortest wavelengths. The electromagnetic waves in each of these bands have different characteristics, such as how they are produced, how they interact with matter, and their practical applications. The different types of electromagnetic waves are defined by the amount of energy carried by or possessed by the photons. Photons are bundles of wave energy. The energy of a photon is given by the equation capital letter E is equal to h multiplied to f, where h is the Planck's constant and f is the frequency of the electromagnetic wave. The value of the Planck's constant is frequency in physics is the number of waves that pass a fixed point in unit time. Number of cycles a wave completes in 1 second, and it is expressed in hertz. All electromagnetic waves can travel through a medium, but unlike other types of waves, they can also travel in vacuum. They travel in vacuum at a speed of 3 times 10 raised to 8 meters per second and denote as c, the speed of light. The wave speed, frequency, and wavelength are related by the following equation. Small letter v is equal to lambda times frequency, where v is the wave speed, or c, speed of light expressed in meters per second. The frequency is expressed in hertz, and the wavelength is expressed in meters. Since all the electromagnetic waves have the same speed, and that is equal to the speed of light, as wavelength decreases, the frequency of the wave increases. In a problem, if the value of the wave speed is unknown, you can use the constant value of the speed of light, which is 3 times 10 raised to 8 meters per second. Don't you worry, I will make another short video discussion purely for the wavelength, frequency, and wave speed problems. Just follow with my latest videos. So for now, let us have first the electromagnetic spectrum topic. From among the electromagnetic waves, the gamma rays have photons of high energies, while radio waves have photons with the lowest energies. This figure will give you a clearer idea of the characteristics of the electromagnetic waves as their sizes are compared with visible materials. Table shows the relative wavelength, frequency, and energy of each of the different types of electromagnetic waves. Through the years, the advancement on the knowledge about electromagnetic waves led us to a modern technological world. After learning about the wavelengths and frequencies of the different types of electromagnetic waves, always remember that all electromagnetic waves can travel through a medium, and they can also travel in a vacuum. And as wavelength decreases, the frequency of the wave increases. Kindly follow my next video presentation that will help you to learn more on the characteristics of each electromagnetic waves and their uses, as well as their applications to our daily living. Please subscribe my YouTube channel Science Time Discussion by clicking the button. Thank you!